Okay, this lesson is 2.7, factoring and solving quadratics. So if you're looking at your notes, we're going to skip this review. This is just a review of factoring. And let's start here with the zero product property. So the zero product property, it is just simply saying that if we multiply, in this instance here, if we multiply A times B and it's equal to 0, then anytime we multiply two numbers together and get 0, one or both of those numbers has got to be equal to 0. So for example, if we have 2x is equal to 0, well, 2 times what number would be equal to 0? That would be x equals 0. In the statement here, it says given r minus 2 and s plus 1. So the quantity r minus 2 times quantity s plus 1 is equal to 0. So in order for this statement to be true, in order for these two to be multiplied together and be equal to 0, then what would we plug in for r? So what would be the value of r that would make r minus 2 equal to 0? That would be a positive 2. And what would we plug in for s? So what would be the value of s to make s plus 1 equal to 0? That would be negative 1. So if r is a positive 2, we would have 2 minus 2, which is 0. And 0 times anything would be 0. If s was a negative 1, negative 1 plus 1 would be 0. Anything times 0 would be 0. So this property here is actually a property that we're going to use today in solving by factoring. And so if you look at this example here, so we have x minus 4 and x plus 7 is equal to 0. So we're trying to find out what makes this statement true. So to be able to make this statement, or to find out what makes this statement true, we want to find out what makes x minus 4 equal to 0, and we want to find out what makes x plus 7 equal to 0. So solving x minus 4 equals 0, I'd add 4 to each side. I'd find out that x equals 4, so there's one solution. X plus 7 equals 0, subtract 7, and I get x equals negative 7. So for this example here, when x equals 4 or x equals negative 7, then that statement is true. Okay, and basically here, this is not in your notes here, but I want to just give you kind of an overview of what we're getting to today. So basically, what we're going to do today is we're going to take a quadratic that looks like this. We're going to factor the quadratic. So when we factor this, factors of x squared would be x and x. This sign is positive, so that always tells me that the signs are the same. I look to the middle term, and that's going to tell me what both signs are going to be. So both signs would be positive. And then factors of 6, I've got 6 and 1 or 2 and 3. The combination of numbers that would work there would be 2 and 3. And here's our test to make sure we have the correct middle term. So we have 2x and 3x, which is 5x. Okay, so this is factored completely. And so now at this point, if we're solving, then we go one step further than what we've been doing the last couple days in class in terms of just factoring the quadratics. So at this point, I've got to find out what makes each factor. So what makes x plus 2 equal to 0? What makes x plus 3 equal to 0? And so I solve each of these, and I would get x equals negative 2, x equals negative 3. Okay, and that's what we're doing today. So the only part of today's lesson that's new or different from what we've been doing in the past is that once we have the problem factored, then we're going to solve it. And we're going to solve it by setting each of the factors equal to 0 and then solving for x. So in these examples here, these are just examples where the problem's already been factored for us. So it's in factored form, and now we want to find out what makes each of these, what's inside each of these parentheses equal to 0. So this would be x equals 5, and this would be -2. Okay, so if I plugged 5 into this first parenthesis, so it'd be 5 minus 5 is 0. 0 times anything is 0. If I plug -2 in for x, in the second parenthesis, it'd be -2 plus 2, which is 0. 0 times anything is 0. Okay. In this second example here, again, the problem's, it's already in factored form. So I set each factor equal to 0 and then solve for x. So to solve this for x, I would subtract 2. So I'd get 5x equals -2. Divide by 5. So I get x equals a -2/5. Here I would subtract 4, and I get x equals -4. Okay, so that'd be our two solutions to that problem. Same thing in each of these examples. Set each parenthesis equal to 0, and then solve for x. So here we would have 2x equals -5, x equals -5/2. Add 6 to the other side, x equals 6. Okay, so let's skip that next example and let's go to these examples here. So we have 2x squared plus 13x plus 21 equals 0. Okay, so basically what we want to do is we want to, first of all, factor this quadratic. So in factoring a quadratic, we're going to look for greatest common factor first. These three terms do not have anything in common. And so we would factor. So factors of 2x squared, 2x and 1x. Factors of 21. So here's our possibilities. We have 1 and 21 or 3 and 7. And if I look at what's going on with the signs, that'll kind of help me further understand what I should do here. So this term is positive, which means both signs are going to be the same. The middle term tells me what they're both going to be. So both are positive. Okay, the factors, let's try 3 and 7. So if we do a little bit of mental math here, if I plug 3 in the middle, so if I plug 3 in here and 7 here, when I test, I would get 3x in the middle and 14x on the outside. Okay, 3x and 14x gives me 17x, so that's not correct. So if that doesn't work, then what I want to try next is switching the 3 and the 7. So this did not work. So now I'm going to try 2x plus 7 and x plus 3. So here's my test. I have 7x, and 6x. Okay, 7x and 6x is 13x. And if we look back up here at the top, the middle term is 13x. That's what we're trying to accomplish for a middle term. So this works. And then once I have it factored, then my next step is to set each factor equal to 0 and solve. So this is the only part that is new from what we've been doing. Up to this point, we've just been factoring the problems. Today we're going to factor and solve. So we're going to factor the quadratic, then set its factors equal to 0, then solve for x. So we get x equals a negative 7/2 and x equals a negative 3. Okay, and those are our two solutions. Okay, the next example, we have 3x squared minus 48. So first look for the greatest common factor. So these two have a common factor of 3. So I'm going to factor out a 3. So if I factor 3 out of 3x squared, that would leave me with 1x squared. Factor 3 out of negative 48, that would be negative 16. Okay, x squared minus 16. This is our special case. This is the difference of perfect squares. So what times itself equals x squared? That would be x. So we put x here and x here. And then what times itself is 16? Is 4. And then our signs would be opposite. So it'd be x plus 4, x minus 4. Okay, don't forget the equal sign and the 0 here. Okay, so now we are going to find out or set each factor equal to 0. The only part that sometimes becomes confusing to some people is that if the greatest common factor is only a number without a variable, then when we get to this step where we're solving, then we pay no attention to this because this is just 3. So in other words, we only want to find out what makes x plus 4 equal to 0 and what makes x minus 4 equal to 0. So we'd solve this, we get x equals negative 4. Solve this, we get x equals positive 4. Okay, so if x is a negative 4, that's going to make the statement true. If x is a positive 4, it's going to make the statement true. Okay, so those are two solutions. Okay, and the next problem, 6x to the third minus 100x squared minus 34x equals 0. First, looking for greatest common factor. Greatest common factor is 2x. So I factor out a 2x from each of these terms. So 6 divided by 2 is 3. Factoring out 1x, so it'd be x squared. Negative 100 divided by 2 is negative 50. Factored out 1x, so it'd be x. Negative 34 divided by 2 would be negative 17. And we factored out the 1x there. Okay, so we factored out the 2x. Now, factor what's inside the parentheses. So factors of 3x squared are 3x and 1x. Factors of 17, the only factors of 17 would be 1 and 17. So if we do a little bit of mental math here, so if I'm trying to figure out where to put the 1, where to put the 17, and so if I do some mental math here, if I put the 17 in the middle here, that would be 17x when I multiply the inside terms together. And then the 1 on the outside, that would give me 3x. So I'd have 17x and 3x. And what I know about the signs is that they're going to be opposite. So if the two terms I get are 17, so if I get 17x and 3x and the signs are opposite, then I would be looking at the difference of those two. So the difference of 17 and 3 would be 14, so that's not going to work because we're trying to get a negative 50. So 1 and 17 in that order doesn't work, so let's try a different order. Let's put the 1 in the inside and the 17 on the outside. So 1 times x would be x. 3x times 17 is 51x. The signs are opposite, and so the difference of 51 and 1 is 50. And in order to get a negative 50, the bigger number would have to be negative. So it'd be negative 51x and a positive 1x. So we'd end up with 3x plus 1 and x minus 17. I'm just noticing here I forgot to put equals 0 on each of these. Okay, so now I have this factored completely. So now my next step is to set each factor equal to 0. And this time, because the first term, because my greatest common factor had a variable, then I've got to find out what makes 2x equal to 0 also. So I set 2x equal to 0. I set 3x plus 1 equal to 0. And I set x minus 17 equal to 0. Okay, so 2x equals 0. Divide by 2, x equals 0. 3x plus 1 equals 0. Subtract 1. Divide by 3. X equals a negative 1/3. And on the last one, add 17. So x equals a positive 17. Okay, so I have 3 solutions this time. X equals 0, x equals negative 1/3, and x equals 17. Okay, in this next problem, one thing we need to pay attention to and notice is that before we can factor the problem, all terms have to be on the same side of the equal sign, and we want to make sure it's set equal to 0. And in the process of doing that, we want to make sure that the first term, or the leading coefficient, is positive. So we want to leave the 2x squared on the left side because it's a positive right now. And that means that to get 17x minus 15 to the other side, I'm going to have to minus 7x. So that would give me 2x squared minus 7x. And then I would have to add 15. So I'm going to add 15 to the left side here. Okay, so now I moved everything so that we're set equal to 0. So it's 2x squared minus 7x plus 15 is equal to 0. And now, once we're set equal to 0, factor. So first, look for greatest common factor. There's not a common factor. So now factor a quadratic. So factors of 2x squared, 2x and 1x. Factors of 15, so 15 and 1, or 5 and 3. If I look at my last term is positive, which tells me both signs are going to be the same. So look here in the middle, and that tells you what they're going to both be. So they're both going to be negative. And now factors of 15, 5 and 3, 15 and 1. Do a little bit of mental math here. We're trying to get a negative 7x. So if you look at this first combination right here, which is really, really tempting, okay, you will see that you end up with a negative 3x and a negative 10x. Okay, and as tempting as that might be to think that that's correct, that is wrong, because we end up with a negative 13x. Okay, so that combination doesn't work. If we switch the order, I'm running out of space here. I'm going to change colors so we can kind of keep track of what we're doing. So if I switch the orders, if I go 2x minus 5 and x minus 3, and now test it, I get negative 5x, negative 6x. Okay, that's negative 11x. So that doesn't work. So then my next option would be to try 1 and 15. And in the essence of time and space here, if I plug 1 and 15 in either combination, that's still not going to work. And so in this particular problem, we can't factor it, which then would mean to us is that there's no real number solution. Okay, and so on occasion we're going to end up with a problem where it doesn't factor, and if it doesn't factor, then that's what the end result is that there's no real solution. Okay, so this example, no real solution because we can't factor it. There's no combination of factors that would work to give us the correct factorization. Okay, next example, 2x to the third plus 10x squared minus 28x equals 0. Okay, greatest common factor here is 2x. So we factor 2x out of each of these terms. So that would leave us with x squared plus 5x minus 14. And we're going to factor what's inside the parentheses. So factors of x squared, x and x. The last term is negative, so I know the signs are opposite. Factors of 14, 1 and 14, or 2 and 7. So if I test, this is 2x, this is 7x. Okay, because the signs are opposite, then I'm looking for the difference of these two. So the difference of 7 and 2 is 5. So to get a positive 5, the 7 would be positive and the 2 would be negative. So it'd be x minus 2 and x plus 7. Now, once we have it factored, now set each factor equal to 0. Okay, our common factor has a variable, so we would set it equal to 0. So 2x equals 0, so that'd be x equals 0. X minus 2 equals 0, so x equals 2. And x plus 7 equals 0. X equals negative 7. Okay, in the next example, x squared minus 36 equals 0. Okay, this is our special case. Both of these are perfect squares. It's difference of perfect squares. So what times itself is x squared? What times itself is 36? And then the signs are opposite. Set x minus 6 equal to 0. Set x plus 6 equal to 0. And solve. So x equals 6. X equals a negative 6. Okay, these last two examples, I'm just going to mention this, and then we're going to do a couple problems from the homework assignment. Remember, before you can factor, you have to get everything to the same side. So in this first example, we would want to subtract 20 to the left side of the equation. And now we could factor. So x and x, this would be 2 and 10. It would be negative 10, positive 2. Then we would set each factor equal to 0 and solve. Okay. On this example here, we would move everything to the left side. So I would have to subtract 9x, and I would have to add 2. And then at this point, we would then factor. Okay, as I'm looking at that, this one appears to be one that does not have a solution. There's going to be no factorization of this that's going to give us a negative 9, because we know both signs are positive. The middle term is negative, so both signs are the same. They're both going to be negative. And this appears to look like it would work, but that's not going to work. That would be negative x and negative 10x, which would be a negative 11x. So that's not going to work. Okay, on the homework assignment, problems 1, 2, and 3. Okay, you are solving linear equations. So problem number 1, 10x minus 20 equals 0. Solve for x. So you would add 20 to the right side, divide by 10, you get x equals 2. Okay, so in problems 1, 2, and 3, you're solving linear equations. Get x by itself on one side and the constant on the other side. So just solve for x. On problem number 4, okay, so on 4 through 21, this is what we just talked about in our notes. So problem number 4, we have 2x squared plus 14x plus 20 equals 0. So first step, look for a common factor. The common factor of these three terms is 2. So we'd have x squared plus 7x plus 10 equals 0. Then factor what's inside the parentheses. So we would have x and x. Both signs are going to be positive. Factors of 10, 1 and 10, 2 and 5. 2 and 5 is going to be the combination that works. So now once we have it factored, set each factor equal to 0. So set x plus 2 equals 0. That gives us x equals -2. Set x plus 5 equals 0. Gives us x equals -5. Okay, next we'll skip to number 6. So number 6, we have 2x squared equals 15x minus 7. So before we can factor, we have to set this equal to 0. So we've got to get everything on the same side. So I'm going to subtract 15x from each side. I'm going to add 7 to each side to move everything to the left-hand side of the equation. Remember, when we get everything to the same side, we want the leading coefficient to be positive. So we want the x squared to be positive. Right? Now look for a common factor. These three terms do not have a common factor. So now factor the problem. So factors of 2x squared, 2x and 1x. Factors of 7 would be 1 and 7. I know both signs are going to be negative. So now do a little bit of mental math here and try to identify where the 1 would go, where the 7 goes. So to get a -15x, if I put 1 here, that's going to give me a -x. If I put 7 here, that's a -14x. -14x and -1x is a -15x. Okay, so once I have it factored, set each factor equal to 0 and solve. So add 1, divide by 2. So I get x equals 1/2. Set x minus 7 equal to 0. X equals 7. Let's skip to number 9. Number 9 looks like one that might be intimidating when you first look at it. So we have x to the 4th plus 14x to the 3rd plus 24x squared equals 0. Okay, these three terms all have an x squared in common. So I factor out an x squared. So basically I'm taking 2 x's away from each of these terms. So this would be x squared plus 14x plus 24. Now factor what's inside the parentheses. So factors of x squared, x and x. Both signs are positive. Factors of 24. So factors of 24, we would have 1 and 24, 2 and 12, 3 and 8, 4 and 6. So if you look at those possibilities and keep in mind that you're trying to get a positive 14x as your middle term. So 2 and 12, that gives me 2x. That gives me 12x. 2x and 12x is 14x. Okay, so now set each factor, including the x squared, equal to 0. So we have x squared equals 0. So what number squared equals 0? That would be 0. 0 squared is 0. X plus 2 equals 0. So we have x equals negative 2. X plus 12 equals 0. X equals negative 12. Okay, and then the last one we're going to do here together is number 11. On problem number 11, we have 9x to the third minus x equals 0. Okay, both of these terms have an x in common, so we factor out an x. So that'd be 9x squared minus 1. Okay, I've had some students today struggle with that part right here. Remember, when you multiply this back out, you have to get what you started with. So x times 9x squared would be 9x to the third. X times negative 1 would be negative x. And then from this point here, what we have to recognize is that 9x squared minus 1, that is difference of squares. So it'd be 3x and 3x plus 1 minus 1. And then set each factor equal to 0 and solve. So we'd have x equals 0. So we'd set 3x plus 1 equal to 0 and solve. Set 3x minus 1 equal to 0 and solve. Okay, and that is your lesson for 2.7. And if you have any questions, make sure check with your teacher, come in and get some help, and good luck.